So, it looks like we are live now. Um, I have up here the first uh, circuit I will be looking at. Let's go. Sorry, I'm just gonna make sure that I can go look at the next circuits as well. Right there. And that one. There. I put it in the detail page, which ones I'm gonna do. So, yeah, we're here. Let's look at this one. It is a high-pass filter made with an inductor. Now, obviously, it sort of gives away what it does. But let's just think of what an inductor does. So, an inductor resists the change in current. So that means that when it is like, okay, let's think. So it resists the change in current. That means that the higher a frequency happens, it looks more like a open circuit. The lower a frequency happens, the more it looks like a short circuit. So, basically, then this will be showing whatever frequency happens to be happening from at this point here, if it's high enough, and this looks like an open circuit. Otherwise, this will look like a short circuit if the frequency is low enough and there won't be any voltage seen here at the out. Let's see if that is right. So yeah, you see at this point, we are basically seeing very little voltage getting put out. Oh, it's sweeping. I see. So that's what that one does. It sweeps. Cool. So now we're at the 400. Let's slow down this simulation a little bit so we can really watch it. Yeah. So now we're going really slow. And then that means that that's basically going to start blocking everything because this will act like a short circuit. Now we're going to start speeding up. And as the frequency increases, then we see a higher max output here. So the 3 decibel point is right about there, maybe 400 hertz or so. Yeah. And yeah, now we're basically letting it all through. Let's go on to the next one. The bandpass filter. Circuits, passive filters, bandpass filter. So, this bandpass filter, effectively what it does, because a capacitor, it acts almost like the opposite of an inductor, like we had just seen. Maybe I should have done the capacitor first. Now we can just do it this way. So the capacitor will act like an open circuit at low frequencies. Because effectively what happens at a low frequency is that it will charge up to the voltage that is being passed there, and then it won't pass any signal because it will just stay charged at that voltage. Whereas, like we said, the inductor does it differently. It resists the change in current, so when you have a low frequency thing, it will start very high and not letting any current through, so it will show the voltage, effectively sending the signal out. But then, as time goes on, it lets that current through, and eventually it just creates a short circuit. Now, in this case, then, you have them sort of competing. So what you can do, and what I'm sure they did here with the calculations, I'm not going to do the calculations of it, but what I'm sure they did is that they would have calculated, okay, I'm going to set this one up to let anything pass, say, 1 kilohertz through, and then I'm going to set this one to what was I just saying? So that's high pass, this is low pass. Yeah, so then this one they would say that we need to let through anything below a certain frequency. So this will let through, say, 1 kilohertz, anything above it, and then they'll say this one, okay, let through anything below 2 kilohertz. So then you let a signal through between 1 and 2 kilohertz. That's what you do. I don't know if those are the right numbers in this one, because that requires some math, but that's what would happen here. Let's just run it. So now you see switching. You can see they're already sort of competing with each other. If you have any comments, please feel free to send them in the chat. I'm looking for my chat right now, but I wonder if I can. Usually, there's chat, and I can see it, but I can't see the chat right here. I don't know why. But we missed it, or I missed it. I was looking for the chat too much. So I'm sure you had seen that the output changed. So yeah, now it looks like must be somewhere around targeting like that 50 hertz. Nope. Well, 35, 40 hertz is what they're targeting. So now you see we're going to switch, and now it will be this inductor stopping the low frequency from getting through. But we can just test that too here. So now you see what I'm doing. I'm testing whether or not this will sort of will just keep increasing. Whether like that this would just basically test my theory whether or not it's the capacitor that stops the signal from going through at a high frequency. And yeah, you see, it is letting that go through at this high frequency. Now, let's add back this capacitor. And yeah, it's basically tamped right down. Now it's letting it come back. And this is where it's really in sync, eh? Now it's going to start going back down, and now it's the inductor preventing it. But let's test that again. And yeah, see, now we're getting that full output again at the low frequency because we've removed the inductor, which prevents the low frequency from being seen. And we'll put that inductor back in. You see what happens is it creates basically a short circuit down there to prevent the voltage from increasing. Yeah. But does anybody have any comments or concerns, I guess? Questions? No? This beer I'm drinking, just I've done it a couple times, but I guess I should have maybe we talked about it before there was a few more people here, but this beer I'm drinking is from Blackbridge Brewery in, I believe, Swift Current, Saskatchewan. It's in from Saskatchewan. Yeah, Swift Current, Saskatchewan. It is a New England IPA. That's just what they called it, the New England IPA. It's very good. So, let's move on to the next one. Is the Astable Multivibrator in transistors. Stop this circuit. Multivibrators, Astable. Yeah. So, now, this one, I probably won't be able to explain it like at all, if any. So if anybody, this would be a great time for somebody to chime in on the chat, just to tell me what is happening with it. Well, there's the chat. Okay, good. Studio. Oh, sorry. I lost my thing here. I want to monitor the chat, but then I click something and it's not there anymore. Live and control room again. This doesn't have a chat. Why? Yeah. Whatever. Nobody has sent in a thing on the chat yet anyway, so. But if you do, please tell me then, or I guess hopefully I'll see it there. Yeah. But anyways, so Astable Multivibrator. Where does the output even come out here? Ah, right there. Okay. So it's basically saying this is the Just give me a second. I'm thinking about what this one will do. I can see it will have something to do with like, so this 5 volts would be applied here, and initially it would uh, have basically 5 milliamps flowing from here to here as some gets charges up this capacitor, which will turn this on, which will have 5 volts there, which will then be charging this up. But then this will also do that. Eventually, these will charge there, and one will shut off the other. So what I'm thinking will be happening, but that seems fairly confusing. Let's just see. Oh, that's what this is. It's little graphs. That's pretty cool. Let's slow down the simulation speed a bit. So yeah, this is turning that on, and this is flowing across the capacitor like that. But then, yeah, it changed. This one's going having a negative voltage, negative voltage, negative voltage. Now it's getting into the positive voltages, and then it changes at that 700 millivolts. Right here, we're at the full 3 volts. It's going right there. Still, that's changing too. So that is effectively what we're seeing, is the multivibrator part of it is that it's charging these capacitors up, and they're put in such a way that eventually, like, so yeah, so about 701 volt or millivolts is what will turn these on. That will keep on increasing until, yeah, just over. Then here, because at this point here, it won't turn itself on. It gets there, and then how does that work? Now I'm just thinking, I can see what is happening there is it switches this from basically millivolts from the like 4 volts or so. So now this is charging. It's charging that capacitor. This capacitor there charges to effectively 3.5 volts or so. And that it I'm gonna slow this down much more here. There is, it's gonna be falling and falling until it basically hits the point. These hit the point where this will go into the off position. And across the capacitor is 2 point. Then we'll get to like 3 volts or so. I've never seen this circuit before. That is not already painfully obvious to you. It's going to get to like 4 volts there. It now changes. See, this still maintains that same amount, but now it discharges the other way. When it starts discharging, then this obviously all goes that way. What it is it's discharging. This is charging the capacitor here, and then when it switches, it's going to start discharging that capacitor through there, which will start raising the voltage seen here, which then will turn it back on. Right now, this is charging this capacitor right here. Up to that 4 volts or whatever it is, which eventually will result in a 700 millivolt amount there or so. You see now it happened and turned that on. And that results in that being turned on. Oh, I see what I did wrong. Just 1 second. I'm gonna cancel this here.